Hello and welcome to part 2 of the mole ratio videos. So, the first part we learned how to go from moles of one thing to moles of another using the mole ratio that we obtained from the balanced equation. Now these types of problems, the two-step problems, they are going to go from moles to grams or grams to moles. So, let's begin. If we look at number 1, it says how many grams of calcium hydroxide are needed to react with 1.5 moles of phosphoric acid. So, as always, we start with our balanced equation, which I have given to you, and because I'm super nice and you guys are the luckiest students ever. And then, once we have that, we can start our problem. So, what we do next is we put our given number. So we have 1.5 moles phosphoric acid. And phosphoric acid is H3PO4. Again, we have to do these special units so mathematica will cancel them out. So we are going from moles of phosphoric acid to grams of calcium hydroxide. So we need to first figure out how many moles of calcium hydroxide are needed. So we look for our mole ratio. And in the equation we have 3 moles of calcium hydroxide for every 2 moles of phosphoric acid. So we put what we want to keep on top, what we want to get rid of on bottom. So 3 moles calcium hydroxide. And again, the special units, don't put the parentheses in this chemical formula because mathematica will get confused and your thing will be messed up. So 2 moles of phosphoric acid. Great. So we already knew how to do that. We're using our mole ratio to go from moles of phosphoric acid to moles of calcium hydroxide. So next, what we have to do is go from moles calcium hydroxide to grams calcium hydroxide. And we already know how to do this. From our mole calculations, we know to go from moles to grams, we need the formula mass. So I'm going to arrow down here and calculate the formula mass of calcium hydroxide. So we have 1 calcium, which is 40.1, plus 2 oxygens, which is 16.0, plus 2 hydrogens, which is 1.0. Oops. And when we shift enter, we get a formula mass of 74.1 grams. So, we go back to our equation. We want to find out how many grams of calcium hydroxide we need. So, we put in the formula mass. 74.1 grams calcium hydroxide. There we go. And that is in every mole of calcium hydroxide. You want to keep your units consistent, so again, mathematica will cancel them out. So good. Now we press Shift Enter, and we get 166.725 grams. But we're not done. We need our final answer in the correct sig figs with units. So our starting number had 2 sig figs, so we have to round this to 2 sig figs, which gives us 170 grams of calcium hydroxide. Good. So I want to just recap what we did. We took our starting number, which was given to us, 1.5 moles of phosphoric acid. We then used our mole ratio to figure out how many moles of calcium hydroxide we have. So we looked at our coefficients, 3 calcium hydroxide moles to 2 phosphoric acid moles. And then from there, we used our formula mass in order to go from moles to grams. So we found out the formula mass of calcium hydroxide is 74.1. That's in every 1 mole of calcium hydroxide. We use that to find out the grams. Okay? Let's do one more. Alright, let me see. What time are we at? 5 minutes. Okay. Let's do one more. So, this question says, what mass of calcium phosphate is produced if you react 0.95 moles of calcium hydroxide with excess phosphoric acid? We got a lot going on here. Don't let the excess phosphoric acid throw you off. Again, it's just saying we have more phosphoric acid than we need. Don't worry about it. We are concerned with how many grams of calcium phosphate is made when we react 0.95 moles of calcium hydroxide. So, what do we always start with? Our given number, 0.95 moles of calcium hydroxide. So we first have to go to moles of calcium phosphate. So we scroll back up. Oh, we don't even have to scroll. We go back up here. We find calcium hydroxide. We have 3 calcium hydroxides for every 1 calcium phosphate. We put what we want to keep in the numerator. So 1 mole of calcium phosphate for every 3 moles of calcium hydroxide. Good. We got our mole ratio from these coefficients. Remember that. Now, next what we need to do is find out the grams of calcium phosphate. So we know from our mole calculations that we need formula mass. So let's calculate that. We have 3 calciums, which are 40.1 grams, plus 2 phosphates, which are 32.1 grams, plus 8 oxygens, which are 16.0 grams. Our formula mass for calcium phosphate is 312.5 grams. Excuse me. And since we want our final answer to be in grams of calcium phosphate, that formula mass needs to go on top. It's 3.125 grams calcium phosphate. And that's how many grams are in 1 mole of calcium phosphate. Good. So now we are going to shift enter. We're going to shift enter, and our final answer needs to be 2 sig figs. So our final answer is 99 grams of calcium phosphate. Okay, good. So let's just review what we did. We started with the given number in the problem, 0.95 moles of calcium hydroxide. We used our mole ratio found from the balanced equation to figure out how many moles of calcium phosphate we'd have. We then took found the formula mass of calcium phosphate and used that to figure out the number of grams of calcium phosphate. Then we rounded to the correct sig figs and got our final answer. So, go through numbers 7 and 8, submit them your answers, and you are all set.